Okay, so we're going to go and apply a linear regression model to this graph. So we did an exponential one, now we're going to try a linear regression model. The same idea, you guys were to create this chart from this graph here. So you're to estimate all the points, and these would become your new x values. Okay, 10 years, and each of these are moving up by tens. So because it's going by tens, it's 1, 2, 3, 4, 5, stuff like that, okay? So, what we're going to do is over here, we've gone through this chart. And what we're going to decide to do is we're going to try to split what we have here. We're going to get a linear regression model. Oh, I better do that in black. That starts from the beginning and goes to 1950. And then we're going to get another linear regression model, goes from 1950 to about the year 2000. So we're going to try to fit two different lines through this. So when we take a look at our regression, we'll go to the full page. When we take a look at this, these are all of the first differences we calculated. So, here are the first differences. Instead of carrying it out together, I did them for us. And our first differences are very different. We go from 1 to as high as it looks like 27. Okay? Again, finding an average would probably be best. What do you think might be a good number to try to use here? Just from the regression itself. What would be? Because remember, these differences stand for our m when it's linear. So the slope to this. So what do we think might be a good slope up to this point? Anyone know? We go from 1 to like 30, so 9 might be a really good one. Let's go with m being 9, okay, for our very first linear regression. Then we're doing another linear regression from 1960 to 2000. These were our first differences. Again, they range quite a bit, from 18 to 110. So, where do we think might be a good estimate here? Wait till a second. Who wants to make an estimate for an m, a slope value through this? No number? Just guess. 110 is probably high since it's the highest.
60.
Yeah, let's go for 60. 60 might work. Okay? So let's try 60. So, our two linear models. For the first however many years, the one we did in red up to the year 1950, we said we were going to have an m value of 9. Okay? So y equals 9x. And b is our y-intercept. We assume the y-intercept to be 1 from what we remember. Okay? The second linear model had a slope of 60. But we couldn't really give it a y-intercept, if you guys notice. Okay? Because if we go back to our graph, at this point, we don't really know where it's going to be, where our y-intercept is going to be. So in order to find the y-intercept for the second one, we have to take a coordinate and plug it in. So we have to solve for b. B will stay as our unknown. And we're going to take an x and y value. So our x value, remember we take these are all by tens. Let's take a value that might be easy to use, 13 and 380. 380 is our y, and 13 is our x. So we get 380 equals 60 times 13 plus b. Times 13 is going to be, let's get our calculator here, 60 times 13, 780. 780 plus b is equal to 380. We bring 780 over, and we're going to end up with a b value of negative 400. Now, obviously for the first regression model, that will make sense. But assuming this has some type of slope like this, negative 400 probably isn't a bad estimate. to where the beginning point would be if we're splitting this into two linear models. Okay, so we're going to go with that negative 400. And we're going to try to apply them both to this transparent graph. Okay, so the first model we had said y equals 9m plus 1. And the second one was y equals 60m minus 400. Remember, the model was split at the year 1950. So we're just going to take our 2 points. Our first point here being 0. And these are going by 10. So 1, 4, 5, 6, 7, 8. This will be the value of 8. Okay? And this one is 1, 2, 3, 4, 5, 6. I think it's about 6 more from there to the year 2000. So I think that one might be at 14. Okay? So we're going to take these values and plug them into our two equations. We're going to plug in 0 and 8 into the first linear model, and 8 and 14 into the second linear model. So our first calculation, y equals 9. Sorry, not m, this should be x. Our x value is 0 plus 1. Our y is 1, which makes sense. The second value we're going to try is 8. Y equals 9 times 8 plus 1. 9 times 8 is 72. So we go with 73. 73, probably somewhere here. Our first linear model is pretty accurate to what we had. We'll see if the second one helps out also. We're going to plug in 8 as the first value. So when x equals 8, 60 times 8 minus 400. Minus 400 is 80. Okay. And our second value when x is 14, y equals 60 times 14 minus 400. Plug that into our calculator. 60 times 14 minus, no, I didn't do that right. 60 times 14. What the heck? There you go. Minus 400 will give us 440. So our two coordinates, our y coordinates are 80 and 440. 80 is somewhere here, and 440 is probably around there. Both of our models are pretty decent fits. The two estimates we made are right along the lines of what this global energy consumption was. So we did some pretty good estimating in our linear regression models for what they had before.